Okay, so let's figure out how to do this delta math. Um, Now, as with all the delta math exercises, you really do need to have um, pencil and paper. Oops, pencil and paper with you. So you're not doing it all in your head. Okay. First thing to do is um, write out the features of this function. Okay. Before we do anything down here, we know there's no negative amplitude. It's the absolute value of this coefficient outside of the sign. So amplitude is going to be 6. We're going to deal with the negative later. Then what DeltaMath calls frequency, we've been calling B. This 3/4 here is our B, but DeltaMath, you'll see in the solutions, we'll call it frequency, and I think it's a good concept. And then midline is -8. Now, before we attempt to do this graph, we have to understand what the B, or quote frequency, does to the period, because we know how high or low it's going to go from the amplitude. We know what the where the midline will be, but remember, for sine and for most trig functions, to find the period, you take 2 pi divided by the frequency, or B, okay? And so how do you divide 2 pi by a fraction? You write it as 2 pi times the reciprocal, okay? And the period, therefore, will be 8 pi over 3. So that's kind of a pain in the butt odd number to deal with. But it's okay when we do these delta math exercises. So this is going to be the period. Okay, so we have the 3 important pieces: amplitude, period, and midline. I know it may be hard to see in this corner, but those 3 pieces. Okay, now let's turn to the screen. Because, and again, it's -6, but we're gonna deal with that in a second. Some of you who like to do the table method, I'm going to kind of sketch it out here. I might not do the entire thing, but remember that if you had x as your as one variable, and then the sign of x, the basic table went something like when you're at 0, sine is 0. When you're at the kind of 12 o'clock, pi over 2, it's 1. When you're at, let's see, 9 o'clock, sine goes back to 0. When you're at 3 pi over 2, when you're at 6 o'clock pointing down, you're at -1. And then when you're back at 2 pi, you are at 0 again. So this is a key pattern to remember about sine, okay? And this may be useful when you do the delta math piece. But if you want to use the table method, then you kind of transform this table by changing the x by this b, the b value, which is 3/4, right? And applying 4/3 to that x. That means it's the reciprocal of this, okay? And 4/3 x, when we apply it to the very last stop along the on the table, 2 times 4/3 is what? Is 8/3. 2 pi times 4/3 is 8/3 pi, which is a full period. That's where we want to end up. When it's at 0, there's no phase shift, so 0 times 4/3 is 0. So the full period will go from 0 to 8/3 pi, and then you're stopping off a quarter of the way in between. And then the sign, the y value is going to be, we have to affect it by what we saw in the formula, -6 sine x. Oh, I'm sorry, -6 of y, where this was the y value, negative 6y minus 8. And that tells us kind of where we are in terms of the vertical part of each point, of each key point. Okay, so a lot of you have been doing this. You take that negative 6 times 0, and it is, and then subtract 8, so it's negative 8. And then when we get to the end, negative 6 times 0, then subtract 8, we're going to be back to where we started, and then it will shift up and down along the way. Okay, so, and then you just kind of follow that if you want to fill out the table. But in the DeltaMath world, where you don't, where it's a little bit more rigid, what you're going to want to do is this. First things, look over here, set the X and Y labels, and the X label is going to be your period, okay? 8 pi over 3, okay? Now, you have to set both X and Y labels. The X label will be 8 pi over 3, and the Y label, actually, I just put 1 every time, because 1 is the kind of value of each of these lines. And so you have a vertical shift, vertical shift of negative 8. It's going to kind of go up and down 8. If you want to make it 2 so you're not making your dots too high up on the graph, that's fine too. But this is less important than getting this piece right. You're just going to want this number to be some comfortable number where you know your graph is going to, the main points in the graph are going to fit here. Okay, so once you've inputted both of these numbers, 2 and 8 pi over 3, you hit done. Okay, and then over here, you're going to see it gives you the dot, which will indicate the end of the period. Okay, and so the period is for the X is going to range from 0 to 8 pi over 3. You can see this. Okay, and now your task is to plot 5 points for one cycle. Well, the first point is going to start at 0, but if you go back to our table and knowing what we know about the midline, it's actually going to start at negative 8. And so it will start here. Okay, so this is the first plot. Now, if we filled out this table, the next stop along the way is kind of, what would it be? 4/3 times pi over 2, which is 4 pi over 6. And then over here you'd have negative 6 times 1, negative 6 minus 8, which is negative 14. Okay? So this is going to be hard to find on this graph because, unfortunately, the vertical lines here don't have little hash marks that tell you kind of the scale of the x-axis. But what you do know is that you go a quarter of the way there. 1/4, 2/4, 3/4, 4/4 to complete the cycle. So just make sure when you plot the next point, which is going to be negative 14, that you go like an equal number of kind of squares. Let's just pick 3. Well, let's just pick 2. 1, 2 squares down to the negative 14. Okay? So I don't know. This is supposed to be 4 pi over 6, this X mark. But again, it's going to be hard unless you want to do a lot of brain damage and fractions between this and this. Now, notice this table has told me something useful, which is that even though this is a sine function, and normally sine functions start by going up, this starts by going down. And that is the effect of that negative here. So this is kind of a negative sine function. It flips over the midline, right? It was normally be the y-axis, but the x-axis, but it flips over the midline. And so this is our next point. The third point will come back to the midline, okay, and which is 0. If you look at our table, 0, minus 8 goes back to negative 8. And that fits the pattern where 0, 0, 0, or 1, 3, 5 stops. 8, negative 8, 1/3, 1 stops 1, 3, and 5 along the way. And I made sure, and I made sure that I went another 2 kind of squares across. So everything is kind of like very symmetric. Then the next stop is going to be, well, negative 1 times 6, which is 6, minus 8. 6 minus 8 is negative 2. Okay. And this stop here is halfway between 0 and 8/3, which we estimated here. Okay, so the next stop would be negative 2. So let's go 1, 2 squares over and hit the negative 2. And then, we'll go 2 more squares over back to the negative 8. Okay, now DeltaMath will be upset when you said that the period goes all the way out to this point when the period of this sine graph ended right here. So what you do need to do is swing that over to let it know that what you've just mapped out is an entire exactly one period from here to here. I was eyeballing kind of like how to get, the same distance each stop along the way until I hit here, and I didn't eyeball it very well. But I do know in between each of these stops, there are exactly two squares, 2 lengths. And so this is symmetrical, which sine wave should be, and it ends here. Okay, so let's see if DeltaMath likes this answer. You may now press submit, since I've plotted 1, 2, 3, 4, 5 points, and I have demarcated this as being the end of kind of one period length. Okay, submit answer. Yay. Okay, and here again, their explanation, we've been using the term B. I kind of like the way that DeltaMath says F for frequency, because the idea is that the bigger the frequency, the smaller the period. If there's a wave that goes, very, very frequently, goes up and down, you would expect that period to be small, the period of one kind of cycle of that frequency. And that's essentially what happens. The larger this F or B, because it goes into the denominator, it'll make the period smaller when this is bigger. When this gets really small, the frequency, and it's very slow, think about a really slow frequency, the period is going to get bigger. Anyway, so that is, when you look at the explanation on DeltaMath, that's how they explain it. Okay, but these are the exercises that you'll need to do in order to kind of make up credit for the quiz. Oh, and just as a reminder, do show all your work. And somewhere around the work, you need to write down the unique ID and circle it that belongs to the problem that you did on screen. Okay.